So this is the example we started on Friday, but we didn't quite finish. And one thing I would like to point out is, because in some of the other classes we had trouble with this. We're adding two fractions. So anytime we're adding two fractions, alright, we can't cross-cancel those two things out because we're adding. We can't cross-cancel those two things out, because what would that give us if we did that? We cross that out and we cross that out. Just give us 1. And does 1 equal to that right there? No, so that doesn't make any sense for us to be able to do that. If we're adding fractions, we can't cross cancel like that. Alright? Just like there's addition on the bottom of this fraction, if this would have been sign on the top, I couldn't cancel the signs out because there's an addition on the bottom. Addition or subtraction won't let me cancel stuff out. Alright, does that make sense to everyone? So I don't know, I'm just going to work this problem out for you, and then I'll give you another example, because I know some of you are. Anytime you've got a fraction, more than likely you're going to have to find some sort of common denominator before it's over with. Our common denominator in this, well, we can always find a common denominator by multiplying the denominator of the left fraction and the denominator of the right fraction. Or if there's 3 fractions, we could multiply all 3 denominators together. Alright, so if I multiply those denominators together, multiplying this times this, I'm not going to fool it out. That'd be cosine A times 1 plus sine A. So all I did was multiply this times this. Is there anybody confused on what I did there? Now, what I have to do is I have to figure out, what did I multiply this first fraction by? This one. What did I multiply it by to get the denominator on the bottom here? What did I multiply? I multiplied it by what? Cosine A. So if I multiply the top, I multiply the bottom by cosine A. What do I got to do? What if I multiply the top by that? What do I have? Right. Or cosine squared A. It's the same thing. I just want you to become familiar with hearing it both ways, depending on what your teacher says. Alright. And it's addition, so that's not going to change. So what did I multiply the top of the numerator, or this other fraction by, on top and bottom? I've multiplied it by 1 plus sine A. So I've got to multiply 1 plus sine A on the top there. So that's 1 plus sine A. And then, do y'all see how this is 1 plus sine A times 1 plus sine A, right? So I could just write 1 plus sine A, the whole thing squared. The whole thing is squared. So what does that mean I'm going to have to do? Full it out. Alright. So if I full that out, alright, y'all have it on your paper, but I'm going to rewrite it on the next piece of, I'm going to write it on the next page. Alright. So we've got cosine squared A on the top plus, now you can go over to the side and full it out, whatever you need to do. I'm just going to write it out like this. Oh, that's not cosine. That's a sine. That's sine squared A, in case you can't read that. And then we've still got cosine A on the bottom. Okay. So has anybody got any questions where I got any of that from? All I did was full out that part in red right there. I fold this out on the next page is all I did. Okay, so now you see this numerator of this fraction is all addition, right? And then addition, I can change up the order. If I had 3 plus 2, that's 5. If I had 2 plus 3, it's still 5. It doesn't matter what order I do it in. So is there two things up there that I could group together that look like one of our identities over here? Right, I can rewrite this so I can group the cosine squared and the sine squared together. So if I wrote the top again, let's see, so it would be cosine squared A plus sine squared A plus 1 plus 2 sine A. Okay, so now that I've grouped this together, alright, I can rewrite this right here as what could I plug in there? I just plug in 1. I can replace that with a 1, and then I have 1 plus 1. Alright, so my new numerator would be 2 plus 2 sine A over cosine A times. Is anybody confused on what I did there? Does anybody got any questions? Alright, so what could I factor out of this top? Could I factor something out of the top? I could factor 2 out. So if I factor a 2 out, what have I got left in that parentheses? 1 plus sine A. Alright. Now what could I do? Why am I able to cancel it out now and I wasn't at the beginning? Here. So I'm multiplying 1 plus sine A times 2 and 1 plus sine A times cosine. Since those are both multiplication, I can cancel that out. And it just equals 1. And I'm going to go through the next. So that would give you 2 over cosine A. And 1 over cosine is what? So if I wanted to, I could rewrite this as 2 times the cosine of 2 times 1 over cosine. If that helps you see it better. That's exactly what this means. 2 over cosine A means the same thing as 2 times 1 over cosine A. How can I rewrite cosine 1 over cosine A? Secant. So it would be 2 times secant A. Is that what I wanted in the beginning? Yes, so that's verified. The main thing to remember in all of this is if you can remember your trig identities, alright, the reciprocal identities and the Pythagorean identities, plus tangent is equal to what in terms of sine and cosine? It's sine over cosine. Tangent is sine over cosine. If you can remember those things, alright, as long as you substitute in for something that's true, even if you go all the way around the world, it'll still work out eventually. Alright, you may have to replug stuff in or something of that nature, but it'll all work out eventually. Does anyone have any questions on this problem? So I'm going to give you a couple minutes. I want you to try this one on your own. So what have we got to do first? Alright, what's it going to be? Alright, so it'll be 1 minus sine x times 1 plus sine x. Okay, so here's something I do want to point out. I don't know if y'all have talked about this before, but what does this look like to y'all? Does this remind y'all of anything the way this is written? What if this is just a side note, so y'all don't have to write this down. Alright, y'all don't have to write this down unless you want to. Alright, if I have x minus 2, times x plus 2, what would... I don't have to full that out, I should just know what that is. It's just what? X squared minus 4. Because if I factor that, it's a difference of what? Squares, and it gives me this. So the teacher I had, Mayhall, we call this FOIL if we had to multiply it all out. I don't know how he came up with this name. I don't even know what the letters mean, but he called it flow. If the two parentheses are the same, other than the plus and minus sign in the middle, all you got to do is multiply the first terms together. So it'd be 1 times 1, which would be 1, and then your sign in the middle is going to be minus, like it was in the bottom there, and then sine x times sine x is sine squared x. And I'll rewrite that bigger in just a second. But if you've got room, you could go ahead and write it.
So that's our common.
So our denominator really, normally if it's something complicated, you wouldn't want to full it out right off the bat. But since this is not really a FOIL, it's like a difference of squares backwards. Alright, it's already factored, and you got to multiply it back out. I want you to be able to see that. So if it's parentheses are the same except for the plus and minus sign, I can go straight. So all I did here at the bottom was multiply the x's together, x squared. 2 times 2 is 4. Put a minus sign in the middle. And if you full it out, though, if you don't see that and you full it out, you're still going to get the same thing. It would still give you that. Okay, so I'm going to erase the side note here. Alright. So, really our common denominator is going to be 1 minus sine squared x. Alright, so I'm not even going to write anything on top of that yet. What did I multiply? I'm just going to leave that in the middle so y'all can see it. What did I multiply this first fraction by? Well, I have to multiply it by on top and bottom to get this common denominator. Alright. One plus sine x. Alright, so if I multiply this top by 1 plus sine x, alright, you can just, actually I will write it. I am going to write it here. So that's cosine x times 1 plus sine x minus, we're going to have enough, yeah. Alright. It would be cosine x times 1 minus sine x. Is anybody confused on where I got that top at all? It's just what I had to multiply the numerator by. Yes? Alright, this bottom's 1 plus sine x. So to get the common denominator here, I have to multiply it by 1 minus sine x to get the common denominator. So I have to multiply the top by 1 minus sine x. Alright, so we're not, we got time. Alright, so this is going to be, I am going to have to distribute the cosines out. Alright, so that's going to give me cosine x plus sine x. All right, now here's the tricky part. When I distribute this part out over here, this is negative cosine x times 1, so that's negative cosine x, and it's negative cosine x times sine x, so that's going to give me plus cosine x sine x. Alright, is anybody confused on what I did right there? Plus, because this is distributive property, so this is a minus here, times a minus here. It gives me a plus here. Okay. So I got to go over to the next page. Well, first, before we do that, y'all see how the cosines have different? This one's plus, and this one's minus. Does everyone see that? Those will cancel out. So then I've got to add this one, because it's plus and plus. And is it the same thing? Alright, so when I add them together, it's going to be 2 cosine x sine x, and then I've got 1 minus sine squared x on the bottom. Alright, what could I change that denominator to? Cosine squared x. Because I can manipulate this top theorem. Alright, instead of 1 minus cosine squared, I could do 1 minus sine squared and make it equal to cosine squared. So I could plug in cosine squared to the bottom. Alright, so that's 2 cosine x over cosine squared x. Then what would happen to one of the cosines? One of them would cancel out. So that'd give me 2 sine x over cosine x. And sine x over cosine x is what? Alright. So that's verified.